Welcome to the channel Einstein Mechanics. We are going to talk about higher order derivatives today. So in the previous videos that we've been doing, we've been taking only the first derivatives. We differentiate it once. But with the higher derivatives, we would differentiate it twice, thrice, and so on. So let's start with an example. Given the function f of x, which equals 3x cubed minus 8x squared plus 4x minus 9. So if we are asked to find f prime prime of x, f prime prime of x means the second derivative of the function. So to get the second derivative, we are definitely going to find the first derivative first. So f prime of x will be equal to, then we differentiate the function. So when we differentiate this, you are going to get 9x squared minus 16x plus 4. So this is the first derivative. Then you differentiate the first derivative again to get the second derivative. So the f prime prime of x, we will be differentiating this one to get 18x minus 16. As simple as that. So that is the second derivative of this function. It's 18x minus 16. Let's take another example. Suppose we are supposed to differentiate the function s cubed cos x. S cubed cos x. So as usual, we will first of all take the first derivative. This one we are taking the second derivative, so we will need the first derivative before. So this is a product. We have s cubed here and we have cos x here. So we use the product rule to differentiate it for the first time. And we see the resulting derivative if the product rule or whatever rule that will help us differentiate it for the second time. So for the first time, it's obvious that we are supposed to use the product rule. So we have f prime of x to be, we will hold s cubed and we differentiate cos x. When we differentiate cos x, we will get negative sine x plus, then we hold cos x. When we differentiate s cubed, we are going to get 3x squared. So f prime of x can be rewritten as, let's bring the positive side first. So we can write it as 3x squared cos x minus x cubed sine x. So this is the first derivative. Then we differentiate the first derivative to get the second derivative. So f prime prime of x will be equal to, so we have product again. This expression here is a product and this too is a product. So we deal with it one after the other. So we have a constant here. So let's factorize the constant out. That's the 3. Then differentiate the s squared cos x. So applying the product rule, I will hold my x squared. Then I differentiate cos x. If I differentiate cos x, I'll get negative sine x plus, initially I held s squared and differentiated cos x. So here I am differentiating s squared and holding cos x. So cos x is here. When I differentiate s squared, I'll get 2x. So I'm done with the first part. Minus the second part. So the second part too is a product. The product of s cubed and sine x. So I'll hold my s cubed. If I differentiate sine x, I'll get cos x plus, then I hold sine x. If I differentiate s cubed, I'll get 3x squared, right? Okay, so let's simplify. So f prime prime of x is going to be, I have 3 here. This will be negative x squared sine x plus 2x cos x minus, we have x cubed cos x plus 3x squared sine x. Okay, so we can expand the bracket to see what we are going to get. So f prime prime of x is going to be, I'm going to get negative 3x squared sine x here. Then 3 multiplying 2x cos x will give us positive 6x cos x. Then negative x cubed cos x and negative 3x squared sine x. So further simplification is going to give us, we have negative 3x squared sine x and negative 3x squared sine x here. So you can add them. So you can get 6x cos x minus s cubed cos x minus, then we are adding these two. So you're going to get 6x squared sine x. So the final answer is going to be 6x cos x minus s cubed cos x minus 6x sine x. Or you can maybe do some factorization to make it beautiful. You can factorize x cos x out here. We're going to get 6 minus we factorized cos x, so 6 minus x squared minus 6x squared minus sine x. So this is going to be our final answer. So when we take the second derivative of this function, we are going to get x cos x multiplying the expression 6 minus x squared minus 6x squared sine x. Okay, let's move on to another example. Okay, let's take another example. Let's say we have y equals e to the power negative x multiplying x squared minus 4x. Okay, so we are supposed to find the cubed y over the x cubed of this. So we are taking the third derivative. So we start with the first derivative. The y over the x is going to be, notice that this is a product. We have an expression of s multiplying another expression of s. So we apply the product rule. So let's hold our e to the power negative x. We differentiate x squared minus 4 to get 2x minus 4. Plus, we hold x squared minus 4x. Then we differentiate e to the power negative x to get negative e to the power negative x. So this is multiplying this. Okay. So let's simplify. Get dy over dx equals, we can factor e to the power negative x out. So we are going to have 2x minus 4. We have negative 1 here, so it will multiply everything here. So we're going to get negative x squared plus 4x. So further simplification gives e to the power negative x multiplying, we have 2x and 4x here. So we have minus x squared plus 6x minus 4. So this is the first derivative. Then we differentiate again to get the second derivative. So the squared y over the x squared is going to be, we have e to the power negative s. Notice that after the simplification, we've still gotten an expression of x multiplying another expression of x. So we do to it as we did to the initial one. So we hold e to the power negative x and we differentiate whatever that we have in the bracket. So you are going to have negative 2x plus 6 is easy. Then we hold the negative x squared plus 6x minus 4. Then we differentiate e to the power negative x. We are going to get negative e to the power negative x. So simplifying that one too, we're going to get dy over the x the squared y over the x squared equals, let's make negative e to the power negative as the subject. So we already have our negative 2x plus 6. This is negative, don't forget. So when we factor e to the power negative x out like this, it will be left with negative 1 here, and it will multiply everything here. So the negative x squared is going to be positive x squared, negative 6x, positive 4. So simplifying this, we're going to get e to the power negative x. We have minus 2x here, minus 6x here. So we get something like this. We have x squared minus 8x plus 10. So this is the second derivative. The second derivative will be e to the power negative x multiplying x squared minus 8x plus 10. So let's differentiate that one. So we have the squared y over the x squared as e to the power negative x multiplying x squared minus 8x plus 10. Okay. So the cubed y over the x cubed, that's the final derivative, that's the third derivative that we want. So we hold our e to the power negative x, then we differentiate this to get 2x minus 8 plus we hold x squared minus 8x plus 10. This will give us negative e to the power negative x. Simplifying, we can factor our e to the power negative x out. We already have our 2x minus 8 here. So there will be negative multiplying the whole of this, negative or multiplying the whole of this. So you get negative x squared plus 8x minus 10 like this. So the cubed y over the x cubed is going to be e to the power negative x out. We have negative x squared here. We have 8x and 2x here. So we're going to get 10x. And we have negative 8, negative 10, and it's 18. So that is that. So this is what you're going to get at the end of the day. All right, let's move on to the next example. So we have y equals sec cubed x, sec cubed x. We are supposed to find the second derivative, that's the squared y over the x squared of this. Okay, cubed x can also be written as sec x all cubed. So here we can apply the chain rule to take the first derivative. So let u equals sec x. When we differentiate u, the u will be equal to the u over the x will be equal to, when you differentiate sec x, you get sec x tan x. All right. So if u equals the whole of this, then I can say y equals u to the power 3. So dy over du is going to be 3u squared like this. Okay. So dy over the x is going to be dy over du multiplying du over dx. Okay, so substituting everything here, dy over du is 3u squared, which is multiplying du over dx, that's sec x tan x. But mind you, we have our u to be sec x, so we can put the sec x here. Get sec x all squared, sec x tan x. So dy over dx is going to be 3 sec, we have 3 of them, so sec cubed x tan x. So when we take the first derivative of sec cubed x, we are going to get 3 sec cubed x tan x. Then we take the second derivative of the first one that we just had to get the second derivative. So let's clean everything on the screen for a little bit of space. So our dy over dx was equal to 3 sec cubed x tan x. Okay, so our second derivative, taking the second derivative, is going to be something like this. We have a constant here, so let's bring the constant out. We have sec cubed x plus, sec cubed x tan x multiplying 3. So the 3 is constant. That's why we've brought it out. And then notice that we have sec cubed x multiplying tan x. That means we also have another product here. So what we do is we apply the product rule. So you see, it's very interesting. All that you have to do to just keep on using the rules and everything that we've learned. That's all. So let's hold the sec cubed x and differentiate the tan x. If we differentiate tan x, we're going to get sec squared x plus, so we held sec cubed x and we differentiated tan x to get sec squared x. So here, let's hold tan x. Let's hold tan x and differentiate sec cubed x. Mind you, this whole resource is the resource that we obtained when we differentiated sec cubed x, if you remember. So if we put that here, we're going to get 3 sec cubed x tan x here, like this. So d squared y over dx squared, this is interesting. 3 out, we're going to get sec to the power 5x plus 3 sec cubed x tan squared x, like this. Okay, so d squared y over dx squared can be also written as, we have our 3 here, we can bring sec cubed x out, sec cubed x, so we're going to get sec squared x here plus 3 tan squared x, this is tan squared x. We obtained it by multiplying this and this. Okay, so this becomes our final answer. Very nice answer that we have over here. So that is that. Let's move on to the next example. Okay, let's say we are supposed to find the b, d to the power 4 over dx to the power 4 of e to the power x. It means we are taking the fourth derivative. That's, we are differentiating e to the power x 4 times. Okay, now the first derivative will give us what? E to the power x, right? Let me write it well. So d over dx of e to the power x will give us e to the power x. Then d squared y over dx squared of the resulting, sorry, it will be d squared over dx squared of the resulting, this is the e to the power x, we're going to give us the same e to the power x, d cubed over dx cubed of e to the power x, that's the resulting, will still give us the same thing. So for the exponential function, the e function, no matter how many times you differentiate it, you are still going to get the same, how do you call it, the same answer. So it will be something like, or in general, we can conclude that d to the power n over dx to the power n of e to the power x will still give us the same thing. So even if we have d to the power 100 over dx to the power 100 of e to the power x, we are still going to get u to the power x. So that is that. Okay, let's try solving this one too and see. We will not actually solve it, but we will use it to introduce a new theorem. 3u to the power 5x cos 2x. Okay, so this is also a product, just like we've been doing. Assuming you're supposed to take the fifth derivative, so d to the power 5 over dx to the power 5. Okay, so you differentiate it 5 times, right? You find f prime of x, f prime prime of x, f prime 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 of x, f prime 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 of x. Some two will do it the f prime prime prime, they will do it just f to the power, they represent it by the Roman numeral iv, which is 4 of x, f 5 of x. It all depends. Okay, very good. Now when we have this here and we want to differentiate it 5 times, it's going to be very complicated. We cannot testify that it's going to be very bulky. So when we have a complicated product, we are taking the higher derivative, it is easier to use what we call the Leibniz theorem or the Leibniz formula. The Leibniz theorem or the Leibniz formula to make it very easy. So you will not solve this question. You can try solving it using the normal approach. Then in our next video we are going to talk about the Leibniz, and you will see how it's going to help us learn it. That's the Leibniz rule. So it is used to find the higher derivatives of product when we have maybe y which equals uv, where u and v are functions of x, and we are supposed to take higher derivatives like maybe from dy over, sorry, from d squared y over maybe a squared going. When we apply this, it becomes very simple. So thank you for watching the video. In the next video, I'm going to explain the Leibniz theorem and the Leibniz rule. Then we see how it will help us differentiate the higher derivatives or take the higher derivatives of products. Okay, bye.